So we're looking at first thing is CuO. What does CuO stand here for? That's your copper oxide. If not, cupric oxide. Again, why is the name cupric? All of this naming convention. Please watch the basics to understand the naming convention. And H2 is your hydrogen. Hydrogen. Then Cu is your copper. And H2 is water. I'll not write that. Let's balance it out. I think it's balanced. So those are your product. And first set is your reactant. So you have copper, oxygen, and hydrogen. 1, 1, and none. None, none, and 2. Copper is 1, none, and none. None, 1, and 2. It's clearly balanced. We'll just write the equation, that is CuO, which is solid, plus H2, which is gas, in presence of heat will undergo redox reaction, and there is gas being generated and plus heat. This is an example of exothermic reaction. Now, what are the indicators? This is one thing that you have to keep in mind. So we have first thing is color change. Color change in solid. There's no liquid over here to begin with. So a black solid copper oxide will change to reddish brown, which is a metallic copper, right? I hope you guys have seen metallic copper. This is metallic copper. That's the main thing. Of course, other one is, what else can you see that? It's very obvious. Yes, one is heat and then one is water. Formation of water. And heat release. Whenever we release heat through reaction, it is known as exothermic reaction. Right. Now, we are discussing the reaction mechanism. Let's look at copper and oxygen. Right. So we have copper, it's here, no? Okay, here, oxygen and hydrogen. So look at the atomic number. Look at the valencies. That's why balancing was easy. It's just 1 and 2. Look at the electronegativity. There's quite a bit of difference. So thus making CuO an ionic bond. That's why we need heat. And first, ionization energy and electron affinity. Of course, oxygen has a lot of electron affinity. It badly wants electrons. Okay, so with this in mind, we can clearly see that CuO is ionic in nature, right? While H2 is correct, covalent, non-polar, which is non-polar. While your Cu is metallic bond, and H2O is polar covalent bond. That I'm not going to write. Now we need heat for the copper oxide and the hydrogen mixture to activate. So basically we need heat to break this, right? We need something to break, is it not? So that's the whole point of chemical reaction. We need to break old bonds and create the new ones. Now the question is, where is the oxidation, reduction and all of that? Okay, let's look at it. So I'll explain this in detail. See, in CuO, right, let me start in this manner. In CuO, Cu has a charge of 2 plus. Here Cu has a charge of 2 plus. And oxygen has 2 minus. While when it gets converted to Cu, what happens? Copper is neutral. Right? The charge is neutral. So this is neutral. I'll just write it as neutral. So copper went from +2 to 0. That is, it gained, this happened because it gained electron. So when it gains electron, it is known as, it is reduced, is it not? So copper is reduced. Agree? See, it went from having, no or having less electron to gaining some. And such a scenario is reduced. Again, this is opposite word. Gaining electron means reduced. Right? So when we're talking about H2 is an element form, so there is no charge. This is neutral. So this is from, and you went to H2O. This is, that this is basically polar covalent bond. So H plus. So it went from this to this. So basically it lost an electron. And this is termed as oxidized. Does it make sense? So this is getting reduced while this is getting oxidized. So you can see that they are happening simultaneously. Again, understand it with all of this, right? Everything, as and when you learn small things every single day, it adds up and you will start understanding as a whole. Okay, yes. So that's an example of your redox reaction.